Hello friends, welcome back in the series of video lecture on fluid mechanics. In the previous section, we have studied about the fluid pressure. We have studied about the hydrostatic law, Pascal's law. We have also studied how the pressure variation occurs in horizontal and vertical plane. So from the hydrostatic law, we have depicted that in the horizontal plane, the pressure variation, there is no pressure gradient occurs in the horizontal plane, and if we go downward from the in the vertical plane, the pressure increases at a rate of specific weight of the fluid. So moving on, now this section we will study about the hydrostatic forces on the surface. That surfaces which are submerged in a fluid, the pressure applied by the fluid on the surfaces is known as the hydrostatic forces. So we will going to start for the hydrostatic forces on the surfaces. So first of all, we will see what is hydrostatic force. Suppose a body is immersed in a water surface or any fluid, the pressure gradient always occur in the vertical direction, that is delta P by delta Z minus rho G. This is the hydrostatic law we have studied. So the pressure occurs in the vertical direction. Suppose a body is, it is a tank containing some liquid of a specific weight rho G. So the force exerted by the fluid, this fluid upon the surface, let's say the boundary of the tank is the surface or the vertical boundary, the horizontal boundary, that force exerted by the fluid on the boundary is known as the hydrostatic force. Okay. So we are going to study about the various surfaces like plane surface or the curved surfaces, how the pressure forces act on those surfaces. So here, say it contains water, it is a solid boundary. We have seen earlier the pressure is increasing. Suppose it is open to the atmosphere. This surface is open to the atmosphere. We take atmospheric pressure as 0. We are taking references at the atmospheric pressure. So the pressure which is measured at atmospheric pressure, which is P atm, will be taken as 0 here. So the pressure is 0. As we go down to the down to the free surface, the pressure increases. Here the pressure increases like this, and at the bottom the pressure will be, suppose it is the height h, the pressure is applied in this direction, the force is applied on this surface in the direction, here the pressure is 0 and here the pressure is rho G into h. So the vertical plane is like that, the pressure increasing from 0 to rho G h. So this is how the pressure variation occurs, and this is how the pressure force applied on any surface. And if we talk about, so the center of pressure, it is the point where the resultant force, the force, this is acting in this direction, the force is acting in this direction if we talk about this boundary. So the resultant force is acting at a point, that point is known as the center of pressure. So it is nothing, it is a point where the total pressure force is acting, and it is a point of intersection of line of action of the resultant force. Suppose the resultant force of this fluid which is acting on the vertical direction is, say, F. Here the line of action is where the force is applied, it intersects to the surface where the pressure is applied. That point, at that point, say it is intersecting at that point, this point is known as the center of pressure. Okay, so let's see, first we start with the horizontal plane. Suppose it is a liquid surface which is a free surface boundary open to the atmosphere. It contains a horizontal plane, horizontal surface, which is lying below the free surface at a distance x. at a distance x. So we know that in the plane, horizontal plane, the pressure at every point is same. The pressure intensity at every point is same. Here also the pressure applied in a horizontal plane is same. The only variation occurs in the vertical direction. So here the pressure is same. Say it is 1, it is 2, 3, the pressure will be same. So how can we find the pressure? Suppose if it is x, the height is x. So how can we find the pressure? This pressure is equal to rho g into x. Okay, so force is nothing, it is the pressure into area of the surface. So pressure is, it is nothing, omega h. Omega is the specific weight, omega is rho g, and here h bar is the height of the center of mass, height of the center of gravity of the body. So here center of gravity is nothing, the section, say it is the center of gravity. This center of gravity lie on the horizontal plane. It is also the distance from the this h is equal to x. Okay, so we can write omega into h. This is the pressure force into surface area. Surface area of the plate is A. So this is how we find the pressure force applied on a horizontal plane which is submerged in a liquid. So here the pressure of the center of pressure. So center of I told you what is the center of pressure. Center of pressure is the point where the resultant force is acting. In case of horizontal plane, the center of pressure is equal to the h bar. H bar is the center of gravity. Here center of pressure is equal to the h bar in case of horizontal plane. We will also derive this from some other equation in the forward slide. So if the surface is regular, say it is a regular surface, no irregularities in the surface, and symmetric about any axis, say here about both axes the surface is symmetric. So the CP, center of pressure, will coincide with the G. Center of pressure will coincide with the G. Okay, now we will understand clearly in the coming slides. So moving on, let's talk about the inclined surface. Again, it is the free surface liquid. Take a body, say specific weight of this body is omega. This is the weight, this is the body shown in the diagram, and this direction is y and this direction is x. So here this direction is x and here this direction is y. So this body is lying below the free liquid surface, which is fully submerged in the liquid. Here this body, the top view is showing in this diagram. The center of mass of this body is at a distance h cg from the top surface, from the free surface. So if we have to find the total force which is acting here in the it is also inclined in the inclined surface, we know that the force, the hydrostatic force, is always perpendicular to the boundary, perpendicular to the surface if we are talking about the fluid at rest. So the fluid is at rest in this condition, the pressure is applied in this surface, it will be in the perpendicular direction, in the normal direction. So the total force is, the formula is same, rho g is the specific weight of the water, and h is the height of center of gravity from the free surface. So it is the center of gravity from the free surface. This is h bar, and the area of this plate in the xy plane, this area this total area. So this is how we find the pressure force. This is a total resultant pressure force, rho h into area. So now if we have to find the center of pressure. So center of pressure, the derivation is not much important as per the GATE examination, but this formula, this particular formula is very much important. Many questions asked in the examination to find the resultant pressure force and to find the center of pressure. So this formula is very much used in this to find the center of pressure. Here H star is the center of pressure, taking distance from the free surface to the point where the total resultant force is acting on the surface. Here IG is the area moment of inertia. Area moment of inertia of this body at center of gravity at G. This is CG, passing through the center of gravity along x-axis. So x-axis is this direction. So here x-axis. The I, center of gravity of the body is G. Moment of inertia is IG, passing through center of gravity along the x-axis. Again sin square theta. Theta is the angle of the surface which is lying at an angle theta from the free surface, and divided by area is the A is the area of this plate, and h bar again it is the height of the center of gravity from the free surface, and plus this is again h bar. So here we can say from this equation of center of pressure we can predict, we can say that H star, the center of pressure, will be always more than h bar. This is the height of center of gravity from the free surface by an amount Ig square sin theta upon Ah, this amount. So I H star will be always greater than H. Okay. There is a special condition, H star is equal to H bar when the surface is in horizontal plane. Okay, now moving on. The special case is, let's say there are two cases, horizontal surface, I have to talk about the vertical plane. Now if the angle theta is 0 degree, so this is the surface, here the plate is at angle theta. If this theta is 0, so what will it become? Again is the free surface, it will become horizontal. This plate will become horizontal. So the pressure force will be acting downward on the surface of same intensity. So here say h bar is the height of this plate, which is also the height of the center of gravity from the free surface. So distance of center of gravity from the free surface, h bar. So again total pressure force, how can we find? Omega A h bar. The formula is same for vertical, for horizontal or for inclined. The formula is same. It is just how can we find the h bar. Omega is same, A is same in the both the cases, but here the h is the center of gravity of this portion of the plate which is lying in the horizontal plane. Now if we talk about the plate having angle 90 degree from the surface, so here the pressure force is acting perpendicular to the surface just like this, and we know that this is a force acting in this direction, and we know the pressure is increasing downward. Taking pressure is equal to 0, considering atmosphere, referring to the atmosphere as a reference. So pressure at this point is 0. Moving downward, it will increasing at the rate of omega h. So here, say it is h1. It will become omega 1 h1. Pressure here omega 1 h1, and here pressure will become, say if this distance is h2, it will become omega 2 h2. So here how to find the center of pressure? Theta is 90 degree, so sin theta will become 1. So formula will become Ig upon Ah plus H. So this is how we can find the center of pressure. Considering it, say it is the center H bar, the center of pressure will be lie below to the center of gravity. Here, this point is H bar. Say this point is H bar, and this point where center pressure is acting, which is H star. Okay. So now just we are going to talk about the pressure diagram. Pressure diagram is also useful to find the resultant force and the point of acting of the resultant force, which is center of pressure. So let's just take a moment. How can we make the pressure diagram? Similarly, as that I have talked about in this diagram, the pressure force is increasing in the vertical direction, and here the pressure force is constant in the horizontal direction. So in the horizontal direction the pressure is constant. Here the pressure is constant. It is P is equal to omega H. H is the height of this plate. Okay. In a vertical direction, this is the plate. This is the plate, and omega 1 H1, as I told you earlier, the pressure is acting here is omega 1 H1, and here the omega 2 H2. It is increasing linearly at a rate of specific weight of the fluid. So here, this is the pressure diagram, which is this is the pressure diagram. And similarly for the inclined plate, this is the inclined plate. Here also omega 1 H1 is acting here and omega 2 H2 is acting in this direction. So this is the pressure diagram. So for horizontal surface, the pressure diagram is a rectangle, and for inclined and vertical surface, the pressure diagram is trapezoidal. Okay. So we can say, if we have some width of the plate into the paper, so this trapezoidal, it will become a trapezoidal prism. It will become a trapezoidal prism. So the volume of the pressure diagram, that diagram of the pressure prism will become, if we find the volume of the pressure diagram, we can find the total pressure of force. Okay. The centroid of this pressure diagram is the center of pressure. Okay, centroid of this diagram. In this diagram, we can understand clearly. Say, in the vertical plate, taking its side surface, the pressure is acting again this way. It is the trapezoidal form. It is a pressure diagram form. And in the 3D diagram, we can say this surface is the plate. This is the plate, and this is the omega 1 H1. Here also omega 1 H1. Moving downward, this will become omega 2 H2, and this is the slope of pressure gradient. So this will become a trapezoidal prism. This will become a trapezoidal prism. So to find, if we can find the volume of this prism, we can find the resultant force. So volume of prism is nothing, is a resultant force that is acting on the surface. Here, it is a resultant force. So the center of gravity of this body, how can we find the center of gravity? This is the formula. We can find the center of gravity. H bar is nothing, H1, which is the top surface of this plate, plus L by 2 is the distance of this plate. For a rectangular plate, the pressure, gravity will be acting at a distance L by 2. Okay, here. So this is the L by 2. L by 2 is nothing, S2 minus H1. And this is how we can find the center of gravity. And to find the total resultant force, that is total force, we just have to find the volume of the trapezoidal prism. So this is the trapezoidal prism. This is the volume of the trapezoidal prism. Here, question may ask directly, if the pressure diagram is given. You can have, if they are asking for to find the pressure resultant force, just find out the volume of that pressure diagram. Okay. And the center of pressure, to find the center of pressure, we just have to find the centroid of this pressure diagram, that is centroid of this trapezium. So this is the formula to find the center of this prism, this trapezium. So just make a note of this equation. You can find the center of pressure by using this formula. So it is all about the center of pressure force applying at the vertical, at the plane surface. Now we are talking about the center of pressure, talking about the resultant force acting on the curved surfaces. Say it is a tanker. It is a tanker containing liquid, say water. So the surface is, it has a round curved surface. Here the water is filled on this container. So we know that force is acting perpendicular to the surface. Here the force is acting perpendicular. To find this, we can say it is the angle theta. The force is acting at an angle theta to the horizontal. It will have the two component, which is one is Fx and another is Fy, downward, which is acting downward. So the resultant force we can find, if we can find the horizontal force and we can find the vertical force, so we can find the resultant force. So vertical force is nothing, it is the weight which is supported by the curved surface over it up to the free surface, free liquid surface. So if we are talking about the vertical force which is acting here, say it is a curved surface, that much of fluid containing up to this curved surface, here up to this curved surface, the weight of this fluid is nothing, this is the vertical component of pressure force. So weight of the liquid supported by the curved surface over it. So we have to just find out the volume. If we can find the volume, multiply it by density, but we have mass, and if we multiply by the acceleration of gravity, we will have rho Vg, it is nothing, force Y, vertical force component. Okay. And to find the horizontal component, here, now if we have to find the horizontal component of force which is acting here, we just have to do what we have done to find the pressure in the vertical plane, considering this horizontal surface as a vertical plane. Here, taking its projection in a vertical plane, this curve has the projection in vertical plane. What will be the area? This curved surface will become projected in the vertical plane. So this will become the now vertical surface. So same thing we have done to find the pressure in the vertical plate, we'll do here. So we have to find the Fx which is acting here. It is the distance h1 and h2 downward here. Similarly, we can find Fx by the formula omega h bar into A. A is the projected area of the curved surface. Here, it is the area of this projected curved surface. So this is how we can find the horizontal force. After finding the horizontal and vertical force, we can find the resultant force here. Okay. So one condition may be arise when the liquid is containing underside of the curved surface. So in this case, we to find the horizontal component, that is Fx, the same thing we have done in the earlier case, we'll do here also. We just have the projected area here. This curved surface is the projected area of this curved surface will become here, and same thing will apply it as we talked earlier. Force omega h bar into A. A is the area of this projected curved surfaces. Now in the vertical, to find the vertical component, we assume an imaginary liquid which is above at this curved surface, up to the height of the free liquid surface. It is an imaginary liquid. After this, the same thing we have to do to find the volume of this and multiply by the density of the liquid and G. This will become the force in vertical direction, but here the force is applying on the surface in this direction, so the vertical component will be upward. Okay, so Fv is nothing, it will be equal to the weight of the imaginary volume of the liquid supported by the curved surface up to the free surface. Here also the Fv will be acting vertically upward because the fluid is on the underside. Okay, so let's just talk about an example. It is a question comes in 2001 in gate examination. A hinge gate of length 5 meter inclined at 30 degree with the horizontal and with water mass on its left. The plate is at an angle 30 degree with the horizontal. Say it is the 30 degree with horizontal, showing in the figure density of the water given, the minimum mass of the gate in kg per minute per unit width required to keep the gate closed. Here, due to water, the force is acting somewhere upward, so we have to find the minimum mass of this gate, so that due to this force which is acting by the fluid doesn't make this gate to open. So that minimum weight required, this is W, this is we have to find out. Okay, so for this, what we have given, first method of doing this question is like that. First of all, we have to do the force balance in this vertical. Let the force is acting in this direction F, and the weight of this gate is acting downward W. So taking at a point, say here, say H hinge, we just have to take the moment equilibrium about that H point. The moment equilibrium due to this force and this force. So this is how we are going to do. So we have area of this plate, this is length at angle theta, density of the liquid. So H bar is nothing, it is the center of mass, center of gravity of the plate. This is the H bar, and force acting is here obviously, so the center of pressure will be here, which is below the center of gravity. So same thing, find the force. What is the force is acting? Rho g, area into H. So density is 1000, 9.81 into area is given 5, and H bar is, if you find this, H bar will comes out to be 1.25 meter. So 1.25 meter. So it will be 1.312.5 Newton. So we have found the force. Find the H star, center of pressure. It will be Ig sine square theta upon area into center of gravity plus center of gravity. Putting the equation here. So for this we have to find the Ig. This is the cross section of the gate BL about X axis passing through G. Sorry. So Ig will be BL cube. This L is the bottom distance. BL cube by 12. So B is nothing. Per unit width, we have to find the per unit width, taking width as 1 meter. LB 5 cube by 12. It will become 1 meter square. Now we have found, put Ig here. Sine square 30 upon area is 5, and again H bar is 1.25. So and plus 1.25 also. So what will we have? We will have 1.667 meter. This is the height of pressure we have find out. Moment about H. So force is acting here. This distance, what is distance will become? This is H star. So then this distance will become H star by sine 30. So F into H star by sine 30. This distance will become H star by sine 30, and it will be equal to the weight weight is acting downward here. So the vertical distance from here, W into the vertical distance of this force weight component, this is the H star, this is the vertical height is H star. So this will become H bar, this is the H bar. So this is the H bar. So this height, this length, this will become H bar into cos 30. So H bar into cos 30. You just have to find the moment about at a point. It will not much very difficult. Putting the values, sin 30 will become 5 and W is nothing, it is mg into cos 30 is 2. We found the cos 30, 2.5, H bar is 2.5 and cos 30. So after solving this, putting G is a 9.81, we will get M is equal to 961893 kg. So we will get 9618.93 kg. So this is how we calculate the mass of this gate. So the close answer is 9618. I think no one is exactly. So 9623. This will be the much closer to the answer. So D is the option. D is the correct option. This is how we are going to find the force acting on a plane surface. Okay. In the coming video, in the next video, we are going to talk about the buoyancy and flotation of a body. Okay. So guys, thank you.